there is a common misconception that about NaNH2 in liquid ammonia and sodium in liquid ammonia. Hello students, welcome back to another class, and today's topic is alkynes. Now alkynes are particularly easier, and we just need to remember a couple of reactions and some basic chemistry like acid and base and nucleophilicity, electron and elimination and substitution reactions. Nothing else to solve the problems from the alkynes chapter. So let's start. Now this question, what is this question asked? Here there is an alkyne and it has been reacted with NaNH2 in liquid ammonia to form I, which is further reacted with this compound, that is cyclopentanol, to form J, and finally it's acidified to give K. So we just need to find out what the product K is. So what does this NaNH2 liquid ammonia does? There is a common misconception that about NaNH2 in liquid ammonia and sodium in liquid ammonia. Now sodium in liquid ammonia reduce the alkynes to transalkenes, but this reagent, that is NaNH2 in liquid ammonia, abduct the acidic hydrogen of terminal. Now only terminal hydrogen possesses this acidic hydrogen, so NaNH2 liquid ammonia only works in acidification in case of terminal alkynes. Now this will what will do? This will abduct this hydrogen to give a salt CH3, CH2, C triple bond, C minus, Na plus. Now this C minus will attack this point or this carbon. This will open up. So this will this type of compound will form C triple bond, C, O minus. Further it will be acidified to give a OH. So now there is also a misconception that this group, that is the ET C triple bond C, this group will abstract the hydrogen from this area because this is acidic. But we must remember that this part, that is this alkynate part, is a nucleophile, is a better nucleophile than being a base. So it will act as a nucleophile rather than a base, and this product will be formed, and hence this product is option B. So option B will be our answer. Never ever write option A or option C as an answer, because this group will never act as base, it will act as a nucleophile. Now let's come to the second problem, and it is just given a set of reactions and we just have to calculate or predict the products one after another, and we just have to write which one of these will be the product C. So it's a very simple reaction. So just we need to know what kind of reagent is given and what this particular reagents does for the reactant. So NaNH2 obviously will abduct this hydrogen as we have previously discussed, and it will give an ion like this, and this anion will attack the Br part and will replace the Br. So it will be like that, CH2, Br, CH3, and it will replaces the Br and will form a product like this. Or we can simply write it like that. That means ethyl group present. Now this group will react with sodium in liquid ammonia. Now we have already mentioned the sodium in liquid ammonia will give a transalkene. So a compound like this, ET, C, triple bond C, ET, on reduction with sodium in liquid ammonia will give a transalkene like that. And the bromine in CH2Cl2 will have a dibromination, and we know already that dibromination occurs from opposite side. So the product will be kind of like that: bromine, hydrogen, single bond, bromine, hydrogen, ET. So this product among the following is option A, like these two group makes the ethyl group: bromine, hydrogen, bromine, hydrogen. So this is our answer for this kind of reactions. These are very basic reactions, as you have already learned. That we just need to know that what this kind of reagent does, nothing else. So now next come to the next problem. This next problem is also very similar to the previous one. This bromine in CCl4 will get attached, and bromine obviously will attack from opposite sides, that is anti-addition will occur. So CH3, CH, double bond, CH, CH3 is obviously a transalkene, and the transalkene, this is a trans isomer. Its trans isomer will form a compound like that. So bromine and bromine, from this to from that one, and this two reagent, alcoholic KOH followed by NaNH2, this will react, or this is used for elimination reaction, and they will follow E2 pathway. What will happen? There is one H, there is another H. First KOH attract this, and this bromine will form, and another time the NaNH2 will attract this one, and this bromine will go away. So this will be a double elimination, and this type of structure, obviously this representation is wrong, because alkynes are always linear. So compound will be like this: CH3, C, triple bond, C, CH3. This will be product A, and hence option B is the correct answer. If you have any doubt on this part, let's go back and discuss it a little more. Now, alcoholic KOH prefers the alkyne to be non-terminal, and NaNH2, being a strong base, will prefer to form a terminal alkyne. But in this case, terminal alkyne is not a possibility, and hence non-terminal alkyne will be the correct answer. But if there is any chance or any possibility of formation of terminal alkynes, NaNH2 will forever prefer to form the terminal alkynes. Remember this point, okay? Now, this is our fourth problem. As you can already see, that this reagent is of very much importance to our alkyne chemistry, because this reagent can be used in various ways. That nucleophile that we can form from using that reagent can be used in various ways. So this reagent works or have very great importance in alkyne chemistry. So as usual, due to that compound, or that this will form, and this will attack the CH3 beer, and the bromine will go away to form a compound like that. Now, Lindlar catalyst. We have discussed in the first question that Lindlar catalyst, or H2 in Lindlar catalyst, will always form a cis alkene. So, on reduction with H2 and Lindlar catalyst, we will get a cis alkene like that: C, double bond, H, C, CH3, H. That means a cis variation. So among these, this is alkyne. Obviously, this is not the answer. this one's a trans, so this is not the answer. This is not the product, so this will also be not the answer. And this one you can see that this is a cis variant. This cis variant will be our answer. Okay, so now the next problem and the final problem on this session. So in this problem it is a little bit of different. So this acidification of this compound will make compound A, which on a base treatment with a base will form B, and upon cold base electrolysis the B will form C. So basically cold base electrolysis is done on sodium salt of carboxylic acids. So we can guess that this A will be a carboxylic acid. On treatment with NaOH it will form a sodium salt and it will form a alkene, alkene or alkyne on cold base electrolysis. So how this will reaction? Let's find it out. On H acidification, this H will get attacked, and after protonation of this oxygen, water will attack this carbon and this bond will break and it will form a compound like this, COOH. Now this on treatment with sodium hydroxide will form salt of this dicarboxylic acid, and this dicarboxylic acid salt on cold base electrolysis will form alkyne, and this will be acetylene. Now how cold base electrolysis works basically? On cold base electrolysis, like RCOONA, if we use cold base electrolysis, what will happen? Two RCOONA will react with each other, this portion will go away and these two R group will get joined, so it will form compound like that. And in this case the compound is like this, CH double bond CH, COONA and COONA. So on cold base electrolysis this part will go away and there will be another bond between these two, so acetylene will form, and C here is the acetylene, so this will be the answer. So we have already seen that alkynes are very much easy chapter to do, so you have to remember the reagents and what they do and you will be all set for the examination. Okay, hope you liked it. So thank you for watching and all the best for the examination. Thank you.